Hey everybody, this is Larry. This is March 5th here in Leetcode land and also New York. Why did I say it so awkwardly? But yeah, today this video I'm gonna do a problem I haven't done before. So let's RNG it. Let's go. Oh, we have a hard one today. So let's take a look. Hopefully it's not too bad because I have to meet up with Fred afterwards. But yeah, 1842. Next palindrome using same digits. Okay, so you're giving 1 2 2 1. Okay, so you have a number with 10 to the fifth number of digits, and we're trying to get the next palindrome. So getting a palindrome is not that hard, given that you already have a palindrome. We have to get the next one. That is kind of tricky. I think it's not that bad in theory, but it is just annoying. But I don't. I think initially that's what I think anyway. But I think the first thing to do is to look at I mean, the first thing to do is break it in half because, that's what a palindrome is, right? So what does the next biggest number mean? The next bigger number means, let's say we have half the thing because the other half is implied. Initially I was going to say, given the second half, we want to just increment we want to increase this one. But I guess that's not true, is it? Because that means that this goes up and then, to kind of in a greedy way, we want to get the next smallest number or next number that is bigger. You want to increase it by as small as possible. So then now you actually want to update the middle digit as much as possible. That means that basically we just try to get the next palindrome or next permutation of half the digit, and that's pretty much it, I think, to be honest. Because it cannot really cross, right? Because if it crosses, then it stops being palindrome. So we only have half the number. So let's just say we have first half is equal to num and over 2. I think that's right. Let's or like I have to make sure for odd digits because sometimes I just mess up on this. So let's see. So this is 12, which is what we expect. Okay, odd number. Okay, so this is where we're wrong. So we just want to round up. That's pretty much it. That's the only difference. But I just want to make sure because I don't know. I guess I've done the math, but I'm a little bit lazy. Yeah. So then now it's 3, 2, 1. So then now we just try to find the next next. I keep on saying it, but next permutation algorithm. And there is a linear one. Well, and for this one you have to do it in linear time anyway. But yeah. There is a linear solution, and to be honest, I have to remember it a little bit. Because there is an invariant where basically you're just trying to find the first number where I don't remember exactly because it just doesn't come up enough, I suppose. But it does come up not often, but just like it comes up once in a while, but maybe not super lot. But basically you just get the next permutation first, and if it doesn't exist, then you return empty string, right? What is the next permutation? Yeah, basically, for example, if you have, I don't know, 1 2 3. I mean, I guess we could play around with some examples. A little bit, also because the digits are not unique for obvious reasons. So then basically you get the last position where 2 is minus 3 and you swap them. Is that good? And then now what, right? And 1 is greater than 2. So then now you have 2. What is the... there is an invariant, but I don't remember it, to be honest. I mean, I know that I can write it out. I'm just trying to, like, And then here, well, 2 3, you wouldn't swap the 2 and the 3. What is the occurrence? Right? To be honest, I don't remember this part. I mean, I'm going to try to. It's such a Googleable thing that, like, So if you want to skip ahead, you should, because it's not. I don't know if I'm going to come up with anything that interesting to say, but I am trying to figure out from first principles, because I'm here to learn. I'm not here to Google. If I'm just Googling, it's not that interesting. And I do notice at some point, but clearly at some point it's not now. So, um, hmm. 'Cause I know that there's something about getting like a number and then the next. Okay, the idea is here then maybe is okay, is there okay, the last number, I guess we can in a way remove the last digit from consideration only because it's forced. So then now the second last number, can we increment this? We can increment this if there's a number that is bigger to the right of it, right? And then basically we're trying to find the last number in which we can increment. And I guess that's it, and then we just sort the rest, which in theory is just the reverse because yeah, it's the reverse of all the digits because of how if this is the last digit to increase, by definition it means that you have a decreasing order, so you just okay, yeah. All right. How do I do that? I mean, I know I'm trying to. I mean, I know that there is like some crazy algos that allow you to do that, like But I'm trying to think. There should be like a very basic operation because I remembered, or I remember having recollection of it, but I don't remember the exact like invariant about it. Um, well, I guess if any number is next to, if any number is smaller than the next number, then it can be a candidate because by definition that is the last number. Because basically here, in a way, you're trying to find the maximum number, because by definition, some number to the left of it can swap. And okay, I think I'm okay with that one. So then basically, now what that comes down to is then now the first digit that is smaller than the next number, this number can be incremented. Okay, fine. So then now maybe I don't know, current is 0, 0. While current is less than n and num sub current. I guess we could start actually at the n, right? At the n. Oh, it's not even n, it's n minus 1. Okay, so wait, maybe I could write n2 for n and a half. As you go to this thing, and then now you have n2, and then now we start at, I think n2, maybe n2 minus 1 to be more precise actually. First of current is, if this is, so I'm going to write some operation. This operation is not quite right. And what happens if they're the same? Well, if they're the same, you keep on going because you can increment this one, this number. Yeah. Okay, so that means that if then we break. So that means that if this is then we do right? Then maybe we do n minus 2. Okay, so then now that means that this number can be incremented at the current index. So then we take the next number that is bigger than this number. How do people? I'm writing this in a way like, I think if you Google, like, this is a very known algo. So if you Google it, you get the clean version. My code is not going to be clean because I'm coming from it from scratch. But all right. So then now we want so basically we're trying to increment current, and we find the next digit after that, I guess. I don't know. Something like this. If first of next digit is, I guess we count from the end because as we said, the invariant is that it's going to be decreasing. So if we count from the end, we can break at the first one, right? So, okay. I guess we can try this again. Next bigger index is right? Is greater than we oh, this is if we break. So if it's smaller than or equal to, we just keep getting smaller, right? So then now, okay, so first to the current, this is the I don't know, I just put it here, right? And then we want to append first next bigger, so the character, and then we want to I wouldn't say swap, it's a very awkward way of writing it. After that, then it's just like after that, then we go from first to current, or like from the end to current, right? So for e for n in range from n to -1, we want to go to current -1. Wait, no, we could skip current. Is that true? When do we put in current? Well, we put in current. Okay, so if first of e is less than or equal to first of current, then we can just append first of e, which else. No, the other way. Well, if this is, or like we always append this, but if this is bigger, we want to append the current part. Like basically like a insertion thing, and then maybe this is very yucky. I maybe I need to look up how to do it. Right? If e is not equal to next bigger, so we don't do this either. And then if not done, then maybe, I don't know. This is very awkward code. I may have to like study this a little bit, but yeah. Oh, we have to return the negative case, which means basically, this never happened. So if current is less than 0, we return to the, otherwise we can just return to the, right? I may be off on this algo. It's very awkward the way I wrote it. Oh, yeah. And of course, we only return half the stuff, so I'm definitely very wrong. But, but I'm also just like wrong in like another way, it seems like. Okay, we have empty string because it's the first string. Okay, and then so this is empty. The next bigger is going to be, should be a 2. Oh, maybe this part ended. Maybe I need to do this. Yeah, okay. So then now this is a 2. This does stuff. But I don't know what. Okay, so after one iteration, it already does this. That doesn't make sense. So then now it starts at the 2, right? And the current is 1, so if this is bigger than it, and we append this. Oh, I have to do a contain here. Oh, wait, no, I don't. But it is bigger than current. Is it this part? That one? No, it includes. No. This. So then the next bigger number is 2. Is it this part that is adding, or the other part? Was the first of current should be 2. Okay, so that means that this is adding first of ye. What is next bigger? Oh, I guess this includes current. Is that right? Did I have it off by 1 on that? Okay, fine. No, that's not true. Next bigger is -1, which doesn't. Oh, so this is actually 1. And 2 is 0. It checks. This is. Wait, what is current? Current should be 0, right? Maybe I'm off by 1 in some place. Alright, current is 0, that's good. Next bigger. Maybe I do need to include the last digit in that one, that's why. Alright, yeah, very silly. Because I didn't include the last one to it. Negative, that's what I don't like about negative indexes in Python. Because it obscured what my expectations are as a result. But yeah. So basically now we want to say answer.append, the reverse of it, and that should be good in theory. Oh, because this should be an extend, because I guess it's just no, that's not true. I mean, it is kind of true, but some of these are strings, so we actually need this to be something like something like that, actually. Yeah, it's a very awkward way of writing it for sure. Ooh. Oh, I forgot the odd number thing. Yeah, I did forget the odd number thing because I was just looking at how did it just accidentally work, I guess. But yeah, I didn't consider the odd number, so that's why it doesn't work, because I'm just outputting missing a digit. Oh, not actually that. I guess it's not even that. It's just that actually this does not include the odd number, right? Because I included it for the next thing, but that's wrong. What I should have done is like, okay, I think I just need cases. Yeah. If and extra is equal, so maybe I have like extra is equal to and then extra is equal to num of just n2 exactly. And then now here we want to pen extra, and then okay, there we go. I just totally forgot about it because I rushed it a little bit. Did I mess this up still? Oh. Because then now this includes that. That's a little bit awkward actually, but okay, fine. Maybe I could just write it this way instead, so that it doesn't use the intermediate thing. But this is definitely a very awkward code. I just kind of forgot about the odd case because I don't know, I got distracted by all the other. But like, yeah, if you know your next permutation thing, or if you're using C++, for example, because there's a C++, yeah, like library for next permutation, then this is pretty straightforward. In fact, I'm gonna upsolve this a little bit using C++, and then see what I can do. Let's just copy this for a second. All right, let's see if I can do it in C++. Right, so I have this. So then, yeah, so I have n is equal to num dot size. I don't know how to write C++ enough. It's been a while. Like, it's just not second nature, but it's fine. And this is yeah, okay, maybe that's fine. Num sub n2. I don't know if this is quite the right syntax, to be honest. But yeah, and then yeah, first. All right, so now you have this, and then now you can do next permutation. I want to say this is true. If next permutation, then we can return first plus extra plus so maybe like R is equal to first dot maybe I don't remember how exactly, so I don't think I'm writing this very efficiently, but or even maybe correctly. Else. But conceptually it's easier if you if you have done C++ stuff. How do I convert a string to a thing again? I don't remember. I forget how to do it, other than like using ATO or one of the other ones. It doesn't really come up that much. Maybe, I don't know. I'm just Googling real quick. I don't know how to convert a single character to it. I guess I can just write something like this as well, maybe. Is it not substring? Oh, like st. I think. Could be wrong. String, substring, C++. I forget what the okay, with an R. Maybe I'm thinking of something else. I mean, this a template that's like a vector thing, but so it doesn't take string. I thought string could be a vector of characters, but I don't know how to convert it. I'm gonna convert it like dumbly, but I really don't know how to do it. Maybe string. You see if there's a clean way of doing it. Yeah, I guess there is. Yeah, that's fine. Maybe. Am I mixing it up? Next permutation, right? Oh, one was. Oh, I am dumb. I'm dumb. I knew that one actually, but I forgot. All right, and then I don't need this anymore. Yeah, some syntax stuff, but it looks okay. Give it a submit. Yeah, much easier because we don't have to do the next fermentation thing. So it's about knowing your library, though. Clearly, I don't know my library other than this function exists. So, but yeah, what is the complexity here? The complexity here, this is linear time. You can kind of see it outright. This is linear time, linear space. I'm a little bit inefficient in the space, but it's still linear. It's just a little bit yucky linear. So yeah, that's what I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.